Welcome back, pre-calculus students. We're going to take a look at finding the inverse cosine and inverse tangent functions now, just like we started with sine. This will look familiar if you watch the sine video. The point of this is to derive from the fact that we need a one-to-one function in order to find the inverse. When we restricted sine, we restricted it from negative pi over 2 all the way to pi over 2. But you can see this isn't going to work. Over the interval from negative pi over 2 to positive pi over 2, we are repeating values, so we can't use this as our restrictions on sine or cosine. But if we bump it over pi over 2, in other words, start at 0 and we end at pi, we pass the horizontal line test. By passing the horizontal line test, we know we have no repetitions. So when we restrict this and we graph it over the line, according reflection over the line, y equals x, we come up with an inverse cosine function that is a function. Anything more than it won't become a function. For similar, again, here's certain reflection points. Key point 0, 1 becomes 1, 0. Pi over pi comma negative 1 becomes negative 1 pi. And this is what our final graph looks like. We get a domain from negative 1 to positive 1 and a range from 0 up to pi. Summarize some of that data and take a look at it in a different way. Inverse cosine, inverse tangent functions. Cosine, we're going to restrict to a domain of 0 to pi, and it's going to restrict from a range negative 1 to 1. If it helps, you can think of this in terms of a unit circle. The unit circle, we're going to look at cosine, we're going to look at the x's. If we went from negative pi over 2 to positive pi over 2, those x values would have repeated. That's why we can't use the same restriction. We start at 0 and we go around the circle until we get to pi before we start repeating x values again. That's why our domain for when we go to restrict this thing is going to be from 0 to pi. The range, the function still negative 1 to 1. That was just like sine. So our domain becomes a range becomes a domain, and we get a domain of negative 1 to 1 with a range of 0 to pi. When we go to graph that thing, again, a quick sketch of it, we do have starting negative 1 is my domain, positive 1 is my domain, and I start all the way up at pi. It's going to come down and ends up at 0. So this is as high as pi. We get as low as 0. This key point right here is 0, comma, pi over 2. The reason why that is cosine of pi over 2 is 0, so when we take the cosine inverse of 0, we get pi over 2. Similarly, with sine of x, f of g of x, or the cosine of cos inverse of x, will actually equal x as long as we stay in the domain from negative 1 to 1. And cosine inverse of the cosine of x will equal x in the domain of 0 to pi. When we go through the process of restricting tangent, some kind of crazy stuff happens, and it's pretty fun. So let's take a look using our graphing GeoGebra program. So here's the graph of the tangent of x. Again, it fails the horizontal line test, so we're going to restrict ourselves to the places where it'll pass it. The easiest restriction is actually that first period, that first iteration of the tangent graph. So there's our restriction. We'll cut it down to everything. Now what's kind of crazy, and this is fun, we're going to reflect this over the line y equals x. Now what that means is if we have vertical asymptotes, when we reflect this, they become horizontal asymptotes. Vertical asymptotes become horizontal asymptotes, and where we previously had restrictions on our domain, we now have no restrictions on our domain, but our range is limited because the vertical asymptotes became horizontal asymptotes. Let's summarize this a little bit in a kind of convenient spot. Tangent of x is going to get restricted from negative pi over 2 to positive pi over 2. For the first time, these aren't inclusive. You can also see that the range becomes from negative infinity to positive infinity, and obviously we won't be able to reach those numbers, so those are non-inclusive as well. Domain becomes range becomes domain. So for tangent inverse, our arctangent, we actually have no restrictions on what our domain is, but our range will never get lower than negative pi over 2, never get higher than pi over 2. Again, if you want to look at the unit circle, how this plays out, if we were to draw the unit circle, we're looking for repetitious values in tangent. Now, tangent gets associated with slope. So we know we've got the first quadrant where all of our slopes are positive. The question kind of is, why don't we include quadrant 2 like we do with cosine? Why are we going down to quadrant 4 like it is with sine? The easiest reason to explain it is this point right here. If we were to try to jump over that, at some point our graph would look like this, and then we'd have a vertical asymptote. That's more difficult in graph than restricting ourselves from negative pi over 2 to positive pi over 2. It just makes a nice little easier graph. And our domain becomes a lot simpler as well. Sketch of the graph then is the reflection over y equals x of tangent of x. And we have a vertical asymptote at positive pi, or horizontal asymptote at pi over 2, and a horizontal asymptote at negative pi over 2. Similarly, tangent of tangent inverse of x is going to equal x from a domain of negative infinity to positive infinity. And we can have the input on our tangent of x to get its identity itself back out is going to get restricted from negative pi over 2 to positive pi over 2. Let's take a look at some of these problems and how they work out. These are some of the basic ones. And again, each pre-calc teacher would do these differently, but I always go back to the unit circle. So it says, what's the cosine inverse of negative square root of 3 over 2? I go to the unit circle, and I'm thinking, you know, for cosine inverse, I'm restricted to the first and second quadrants. So in the first and second quadrants, when does the x value equal negative 3 pi over 2? That only happens at one place, and that's when we have a reference angle of pi over 6. Now, reference angle of pi over 6 is coming back from pi, which means our solution is 5 pi over 6. The more convenient you are with the more familiar you are with the unit circle, the more convenient these problems are. It's just a lot easier. Again, unit circle. When does the arc cosine? So what angle will produce a cosine value where my x is equal to negative 1? My x value is all the way at negative 1 over here. My restrictions are from 0 to pi, which makes pi the solution to the arc cosine of negative 1. Now, arc cosine of negative square root of 26. This kind of looks crazy, and they're trying to fool you a little bit. Arc cosine is the same, you know, will stay the same. But if I were to rewrite this, this is a decimal approximation. It's about like negative 5.1. I can't reach negative 5.1 of my x values. That's like way over here on my unit circle. Because I can't reach those, there's no angle I can rotate around my unit circle to come to that ratio. So this is not possible, or no solution. Arc tangent of negative square root of 3 over 3. Unit circle, I'm restricted for a tangent inverse between quadrants 1 and quadrants 4. So when does my line, again, I always associate with tangent with slope. When does my line have a slope of negative pi over 3 over 3? That's at a reference angle of pi over 6. In order to get to that pi over 6, though, since we have to rotate down to quadrant 4, our solution becomes negative pi over 6. Tangent inverse of 5.5. I bet a lot of you are kind of thinking like I was when I first did this problem. Aha, I know this. This is going to be not possible because this thing's above 1. But you have to remember we're dealing with tangent. The kind of everything gets thrown off the side when we're dealing with tangent. To say what's the tangent inverse of 5.5 means find me how far I have to rotate to get a line that has a slope of 5.5. And we can certainly find that. Unfortunately for us, 5.5 isn't one of our special tangent values, so we're just going to type that into our calculator. Tangent inverse of 5.5, when you type it in your calculator, tangent inverse is right above the tangent, ends up being 1.39. We can leave it blank because it's a radians. Next, it says evaluate the composition of each function. We've seen these before with sine, and now we're just dealing with cosine and tangents. The cosine inverse of cosine. The cosine of cosine inverse of 3/4. 3/4 falls well within our domain, so the cosine inverses cancel, and we're just left with 3/4. Now, the arc cosine of the cosine of negative pi over 7. Our cosine is limited to, when we're trying to find these, quadrant 1 and quadrant 2. Negative pi over 7 would fall into quadrant 4, so that means we can't stick this into our cosine value and have it come out to pi over 7. what would end up happening is, if you were to find this, you would figure out the cosine value of some of negative pi over 7 would end up coming out some positive x value, whatever it is. We'll just call that x. Then the arc cosine of x, the positive x value would end up coming back into quadrant 1, which would then give you this reference angle. In other words, what this would end up being is positive pi over 7 if you were to type in your calculator. Because of this, what has to happen is it's not just pi over 7. Let me try to explain that just again, because I don't think I was very clear. When you ask for the cosine of so when you ask for the cosine of pi over 7, you're going to get negative pi over 7. It's saying, hey, what's the x value after you rotate some degree down negative pi over 7? Whatever that is, we'll call this value x. To figure out what the arc cosine of that is then, to say what's the arc cosine of x, what we would have to do is actually draw a vertical line. When we draw that vertical line here, there is some point where the x value is the same. The reason why we have to draw a vertical line up is because our restrictions on the arc cosine, our range kicks out only values, only angles between between 0 and pi. So what angle would have to be drawn in order to get the same x value is the same reference angle, pi over 7. So the arc cosine of this quote-unquote x value that yielded from the cosine of pi over 7 is pi over 7. Next, the tangent inverse negative 123. We have no restrictions onto our input into the tangent inverse, so the tangents and the tangent inverses cancel. And finally, we get the arctangent of the tangent of pi over 4. Our restrictions for tangent are between negative pi over 2 and positive pi over 2. That falls well within, negative pi over 4 falls within our domain, so we know that arctangent and the tangent cancel, and we're left with negative pi over 4.